Hi dear students, we can continue our discussion in classification of elements. Now I will move to another very important topics, that is ionization energy. Before discussing the details of that topic, I just introduce you 4 questions. You please write down these questions in your notebook and think just for a moment. If you can solve this question now itself, well, I appreciate you. If you cannot solve, don't worry, the subsequent discussion will help you to solve these questions. At the end of this video, I will give you some more previous questions of higher order thinking, and after finishing all these questions and this video, I assure you all the questions, any questions from this topic can be answered. Okay, let us see the questions. First question, what is the ionization energy of 1 mole of hydrogen atom in kilojoule per mole? Second, which element has highest first ionization energy? Nitrogen, oxygen, carbon, this is carbon, beryllium, boron. Third question, which element has highest second ionization energy? Here first ionization energy, here second ionization energy. Nitrogen, oxygen, carbon, fluorine. Fourth question, the first, second, third ionization energy of aluminium are 578, 1817, 2745 kilojoule per mole respectively. What is the energy required to convert 270 milligram aluminium to aluminium 3 plus? How is the question? Yes. Okay. Now, in this question, you have noticed 3 words. One is obviously ionization energy. Second is first ionization energy. Third is second ionization energy. Okay. You know what is ionization energy? Ionization energy required to remove an electron from gaseous state, atom or ion, gaseous state. That is, delta H ionization energy is a positive quantity, that is endothermic. Yes. Imagine an atom, any atom M. This is neutral, but in gaseous state. You just kick out an electron, remove an electron, you will get M plus. This process is called first ionization energy. What you are getting? Uni-positive ion. Again you remove one more electron from here. You will get M plus 2 di-positive ion. Therefore, first ionization energy is the energy required to remove an electron from a neutral gaseous atom. Agree? Second ionization energy it is the energy required to remove an electron from a gaseous unipositive ion. Agree? Therefore, obviously, first ionization energy smaller than second ionization energy, which is smaller than third, which is smaller than fourth. In any case, whatever the elements, first is smaller than second, smaller than third, smaller than fourth. We can take another element. Suppose beryllium 1s2 2s2. After first ionization, you will get beryllium plus now 1s2 2s1. After second ionization, this is first ionization energy. Second ionization energy, you are getting beryllium 2 plus 1s2. Okay? It goes on like this. Therefore, please understand what is first, what is second. The energy required to convert beryllium to beryllium plus, that is called the first ionization energy. That first is smaller than second. You know the reason. Because second electron is removed from a positive charged species. Imagine you have two seeds in your hand. You are holding that. Okay, your younger brother came and snatched one seed. You will protect, but somehow he managed. Agree? The energy put up by your brother to snatch away first seed is called the first ionization energy. Now you are holding the second one. Your brother ran away. Somewhere he ate it. Then he again came. Imagine, again came. He tried to snatch the second one from your hand. How was your protection? You will protect more severe than you have protected in the first case. Because he already snatched the first. Now he is snatching the second one. Therefore, the amount of protection you put up against your brother will be more. That is second ionization energy. This is quite natural. Okay. Now, factors affecting ionization energy. Factors affecting ionization energy. Factors affecting ionization energy. There are different factors: size, second, screening effect, third, radius, fourth, electronic configuration. Electronic configuration. Okay, but we need a technique to answer this question in a simple way. Let us discuss common elements. Look at it here. We can start from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, 1s2, 2s2, 2p2, 1s2, 2s2, 2p3, 1s2, 2s2, 2p4, 1s2, 2s2, 2p5. Agree? After first ionization, you will get lithium plus, beryllium plus, boron plus, carbon plus, nitrogen plus, oxygen plus, fluorine plus. Okay, you will get 1s2, now 2s1, 1s2, 2s1, now here 2s2 because electron is lost from 2p1. This is 2p1, 2p2, 2p3, 2p4. I think you can understand all of this. Now the second ionization, lithium 2 plus, not possible or very high. I will explain. This is beryllium 2 plus. Now you will get 1s2 here. Boron 2 plus, 2s1. Carbon 2 plus, 2s2 because 2p2 complete. Nitrogen 2p1. Oxygen 2 plus, 2p2. Fluorine 2 plus, 2p3. Why alkali metals second ionization energy is very high, very high. Always second ionization energy is higher than its first ionization energy. But in some cases, it will be very high. Very high. Once again, I repeat, normally second ionization energy is greater than first ionization energy. In some cases, it will be very high. When? If the configuration after first ionization energy is noble gas configuration. If the configuration after first ionization energy is noble gas configuration, in such cases, the second ionization energy will be very high, normally not possible. What is the meaning of very high? It will be more than 5 times of first ionization energy. More than 5 times of first ionization energy. Underline this word. More than 5 times of first ionization energy. Suppose your first ionization energy is 300. The second ionization energy is 2000 or 1500. Then 300, 1500. Imagine 300, 1500. It is 1500 is 5 times greater than 300. It means after first ionization, it has attained noble gas configuration. Yes. Now, these are the configurations. This is actually along this period. You know which element has highest first ionization energy? Highest first ionization energy in this element? Fluorine. Because along the period, first ionization energy increases. Along the period, ionization energy increases. But is it in regular order? Along the period, ionization energy increases. But is it in regular order? No. I will give you the order of first ionization energy here. Order of first ionization energy here. Student, please listen. Lithium less than boron, then beryllium, then carbon, then oxygen, then nitrogen, then fluorine. Okay, obviously last neon, noble gas. Have you noticed this nitrogen here, this beryllium here. What is the period? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is our second period. But have you noticed this beryllium came here and boron here. Nitrogen, oxygen here and nitrogen here. Underline, please note down. First ionization energy of beryllium is greater than first ionization energy of boron. Note down again. First ionization energy of nitrogen is greater than first ionization energy of oxygen. Yes. You know why? Because in the beryllium, it has full-filled configuration. Similarly, in the nitrogen, it has half-filled configuration. Half-filled configuration. Yes. Now, second ionization energy order along the period. Second ionization energy order. Yes, for the second ionization energy order, you take this configuration. This is our lithium plus, this is our beryllium plus, this is our boron plus, this is our carbon plus, this is our nitrogen plus, this is our oxygen plus, this is our fluorine plus. You know, the second ionization energy among this is highest for lithium. Highest for lithium. Highest for lithium. Why? It has noble gas configuration. Agree? Yes. Now, lithium is okay. Now in the beryllium, carbon then boron. Carbon then boron. Why? Because in the second ionization energy, boron plus has fulfilled configuration. Please understand, my students. Then nitrogen, then oxygen, then fluorine, then oxygen, then lithium. Why second ionization energy of oxygen is greater than that of fluorine? Because in the second ionization energy, you have to take the electronic configuration of oxygen plus. That oxygen plus has half-filled configuration. Half-filled configuration. Why second ionization energy of boron is greater than carbon? Reason. In the second ionization energy, you have to take the configuration of boron plus and carbon plus. When you compare that, boron has fulfilled configuration. Why lithium has highest? It is because lithium has noble gas configuration. Yes. Okay. Therefore, two questions from that. Couples of questions you can answer. I think you will answer that. Now, calculate the ionization energy. Ionization energy calculation. Could you calculate the ionization energy? Yes. Ionization energy is equal to 2.18. Now minus sign. 2.19 minus 80 joule per atom Z square by N square. Or ionization energy is equal to 13.6 electron volt per atom Z square by N square. For hydrogen Z is equal to 1, N is equal to 1. Therefore, this is enough. This is enough. Okay? Yes. There was a question. What was that question? What is the ionization energy of 1 mole of hydrogen atom. 1 mole of hydrogen atom. 1 mole of hydrogen atom. That was the question. Now we can answer that question. Yes. 1 hydrogen atom. Ionization energy. 1 hydrogen atom. 2.18 into 10 raised to 18 joule per atom. This is the ionization energy of one atom. Therefore, for 1 mole, minus 18 into 6.022 into 10 raised to 23 joule per mole. Fine? Because earlier it was for 1 mole, 1 atom, now it is for 1 mole. But therefore, when you multiply, okay, please multiply this answer. You will get 1.31 into 10 raised to 6 joule per mole. In kilojoule, when you convert into kilojoule, it is joule converted to kilojoule, it is kilojoule per mole. This is answer. Or kilojoule per mole. 13 kilojoule per mole. Mole raised to minus. This is answer. Very simple. Very simple. This is a equation for calculating ionization energy. Okay. This is the equation for calculating energy of electron also. Therefore, this equation can be used to calculate energy of electron, but the condition there should be minus sign. There should be minus sign. Okay. Therefore, you learned what is the trick for determining the ionization energy. Now, I will introduce you a trick or technique for order of ionization energy. Order of ionization energy. Technique for order of ionization energy. Technique for order of ionization energy. Okay. Technique for the order of ionization energy. Order of ionization. What is the technique? If you can write no electronic configuration very simply, then this is order S1, P1, S2, P2, P4, P5, P6. This is order. Ionization energy will be very low if an electron lost from S1. Ionization energy will be very high if an electron lost from P6. Whether it is first ionization energy or second ionization energy. When the second ionization energy question asked, remember you should write the electronic configuration of unipositive ions. Then if electrons are lost from these conditions, this is order. This is because of this. You have one missing. P4, P3, P5, P6. Because of this, nitrogen has more ionization energy than oxygen. First ionization. Because of this, oxygen has more ionization. Oxygen has more second ionization energy than fluorine. Because oxygen has P3, fluorine has P4. Nitrogen has here P3, oxygen has P4. When first ionization energy. I think this idea is clear. If you find any difficulty, you contact me. I will help you. Okay. Therefore, we have discussed the different factors of ionization energy and everything. Now, there was a question. We can do that question now. The question was that the first, I write again that question. The first, second, third ionization energy of aluminium are 578, 1817, 2745 kilojoule per mole. What is is energy? What is the energy? Energy required uh, to convert all atoms of aluminum 2, aluminum 3 plus in 270 milligram of aluminum vapor. Okay, they are asking you what is the total energy for aluminum plus aluminum 3 plus. Listen my students, you are given first, second, third ionization energy in kilojoule per mole. This is value of first ionization energy, this is second ionization energy, this is third ionization. Have you noticed third is greater than second, greater than first? But it is not far greater, it is just 3 times or 4 times, it is just double. Therefore, there is no noble gas configuration. Okay, very careful that. Therefore, total ionization energy to convert 1 mole aluminium from aluminum to Al3 plus is 578 plus 1817 plus 2745 is equal to, let me check the video. Okay, video is okay. The answer, when you compare, you will get 5140 kilojoule mole ratio. Okay, students, you are getting like this. That is total ionization energy for 1 mole. For 1 mole, it is nothing but 5140 kilojoule per mole. For 1 mole, this is for 1 mole. But your question is 27 milligram. 1 mole aluminum means 27 gram. 27 gram. Okay. Therefore, or this is milligram. If you convert to milligram, 27 into 10 raised to 3,000 milligram. 27 gram or this much milligram. But your question is only 270 milligram. Fine. Okay. Therefore, 1 milligram, how much energy? 5740 divided by 27 into 10 raised to 3 kilojoule. Therefore, 270 milligram requires 5140 27 into 10 raised to 3 into 270 milligram. This is the final answer. The final answer will be, okay, you can solve this. 51.4 kilojoule per mole. This is the final answer you will get. Okay, I think this idea is clear. Now, we can solve another question from ionization energy. We can solve another question. I will write the question. You note down the question. First and second ionization energy of three elements are given below. Element, first ionization energy kilojoule per mole. Second ionization energy kilojoule 1 raised to minus 1. Okay. A, B, C. 520, 1680, 2370, 7300, 3380, 5250. Which is alkali metal? Which is alkali metal? Very cunning, simple question. You don't worry about the data. 3 element A, B, C. Its first ionization energy 520. Second is 520, 7300. This is 1680, 3380. This is 2370, 5250. Which is alkali metal? That's the question. You know, when you move from here to here, how many times increase? More than 12 times. When it is just double, 2 times. It is also almost 2 double. Therefore, first ionization energy, after the first ionization, here, after first ionization, noble gas configuration attained. Noble gas configuration attained. That's the meaning. Alkali metal, you know, alkali metals, we know that alkali metal is NS1. N minus 1 P, N minus 1 P, NS1. This is alkali metal because they are group 1 elements. Group 1 element, do you remember? For example, sodium 1s2, 2s2, 2p6, 3s1. After the first ionization, that is when this electron lost, yes, it will get the noble gas configuration. That is the importance of alkali metals. Alkali metal, after first ionization, they will have attained noble gas configuration. How do you understand that the noble gas configuration? Their ionization energy will be, second ionization will be extremely high. Therefore, answer is A. Answer is A. Students, please note down this. In the case of alkali metal, second ionization energy is more than 10 times greater than first ionization energy. Trick 1. In the case of alkali metals, second ionization energy is more than 10 times of first ionization energy. Trick 2. In the case of alkaline earth metals, please note down, write, in the case of alkaline earth metals, third ionization energy is more than 10 times greater than its second ionization energy. Trick 3. In the case of boron family, fourth ionization energy is more than 5 times its third ionization energy. Example, aluminum. You can continue like this in the carbon family also. That I give you. Now we can solve one more question and we can finish ionization energy topics. Yes. 1 mole magnesium, right here. 1 mole magnesium absorbed 1200 kilojoule energy. If the first and second ionization energy of magnesium are 750 and 1450 kilojoule per mole, what is its final composition of the mixture. Very cunning question. Let me check the video. Okay, it's clear. I fear sometimes the video will be offshoot. Okay, it is doing in the mobile. I think you can watch it. If you find any difficulty, you just contact me. I will clear it. I will make more clarity. Okay. 1 mole magnesium absorbed 1200 kilojoule energy. Okay. Yes. What is the composition? Look at here. 1 mole magnesium. You have 1 mole magnesium. It is absorbed this much energy. Its first is this and second. Okay. You know magnesium plus, magnesium 2 plus. For this 750, 1 mole. For this 140, 50. Yes. Imagine, suppose this is a magnesium. First all magnesium become first ionized. Then they will become second ionized. This is the idea. We have only this much energy. Okay. We have only this much energy. Therefore, minus 750. Okay. What is the remaining? Only 450. Therefore, after first ionization of magnesium, in this case, after first ionization of magnesium, only this much energy remained. If you want to ionize magnesium completely into second ionization, you need this much energy, but you have only this much. Okay. Therefore, we can do the calculation. 1450 required to ionize 1 mole of magnesium plus, but we have only this much. This much is remaining because 750 has been utilized to ionize all magnesium into first ionization. Therefore 1 mole Mg plus require 1450. Therefore 1 by 1450 into 450 mole. This much only we can ionize because kilojoule. 1 kilojoule, therefore 450 kilojoule can only ionize this much. What is this value? This is 0.31 or 31%. Therefore, out of 100% Mg plus 100% Mg plus, only 31% is second ionized. Only 31% is second ionized. Therefore, the composition is 31% Mg2 plus 69%. Is it okay? Yeah, Mg plus. Is it clear? Okay. So far we have solved 6 numericals. 6 numericals are 6 windows of ionization energy. 6 windows of ideas. Therefore, you practice it, solve more questions. I assure you, if you are mastering in these 6 numericals, you can solve any question which asked in the ionization energy. Thank you.